Hi, my name is Shahroz Ahmed, and in this video we'll discuss the topic of forces and motion. So in the topic of forces and motion, first of all we'll discuss the motion part, and then at the end we'll discuss about the forces, how the force interact with the motion. So let's start off with distance and displacement. So distance is basically it is the total length covered between two points is distance. For example, we have a point A, we have a point B. A person walks from point A, goes into this direction, then over here, then here, and then it comes over here, and ultimately it reaches point B. So the total length that he has covered in moving from point A to point B is called the distance. The unit for the distance is meter, and it is represented with small m. Now, distance is a scalar quantity. Let me tell you about the scalar quantities and the vector quantities. So the physical quantities that do not have any direction, but they do have some magnitude, like if we can measure them, but we do not know about their direction, then such quantities are the scalar quantities. And the quantities that are measurable as well as they have some direction, so those quantities are the vector quantities. So in this one, distance, because we are not sure about the direction of the distance from point A to point B, so we can call it as a scalar quantity, but we can measure the distance. So measuring magnitude is possible, but measurement of direction is not possible, so this will be considered as a scalar quantity. Now the next thing that we have to discuss is the displacement. Alright, so displacement. So for example, we have point A over here, we have point B over here. If I move directly from point A to point B, then this is the shortest path from point A to point B. So by definition, we can say the shortest path between two points is called the displacement. The shortest path between 2 points is displacement, and we represent, and the unit of displacement is same as of distance. Let me just write the spellings. Displacement, so unit is same, but the difference between the distance and displacement is that the distance is a scalar quantity, but over here displacement, because it possesses a direction that is headed towards B from A, so it's a vector quantity. So displacement is a vector quantity because it possesses a direction. Now after this we have to discuss about the speed and velocity. So let me just erase it. Alright, so speed is basically the rate of change of distance is speed. So we can say that speed is equal to distance over time. So whenever I say the rate of change, it means something is being divided by the time. So over here I have said the rate of change of distance, so it will be distance over time. Okay, so speed, the unit of speed is, we can just represent speed with s, distance with t, and time with t. So the unit for the speed is meters per second, and speed is a scalar quantity because it's distance over time. So distance is a scalar quantity, time is also a scalar quantity. Both of them can be measured, but they do not possess any direction, so speed will also be a scalar quantity. Now Now I'll discuss about the velocity. Alright, so velocity. So velocity is basically the rate of change of displacement. The rate of change of displacement is velocity. So I can write it as velocity equal to displacement divided by time. And I can write it as v equals to d by t, and the unit of velocity is same as of speed, that is meters per second. And over here, as we can see, that the displacement has a direction but time does not have any direction, so velocity will possess a direction. So due to which velocity is a vector quantity because it possesses a direction, so it's a vector quantity. Now the next thing that we have to discuss is acceleration. Alright, so acceleration is basically, it is related to velocity. So we can say that the rate of change of velocity, is the acceleration. So we can say acceleration is basically equal to the change in velocity over time. We can also call it average acceleration. And there are two types of acceleration, basically average acceleration and instantaneous acceleration. In the average acceleration, we take the initial velocity and the final velocity, that will be called the change in velocity over time. In the instantaneous acceleration, we just take the velocity at a particular instant. So but overall we can say that acceleration is equal to change in velocity over time, and we can represent acceleration with small a, that will be equal to delta v by delta t. Delta v means the change in velocity, and the delta t is basically the change in time, and a is for acceleration. Now coming towards the unit for the acceleration, the unit for acceleration is meters per second square. So this is the unit for acceleration. So now after this we'll discuss about the displacement time graph. Alright, so now we have to discuss about the displacement time graph. So in this displacement time graph, we will see how the displacement time graph helps us to find out the velocity of any object. So let me just draw a graph first as an example. So this is the y-axis of the graph. Let me just draw a straight line. This is the y-axis of the graph, and over here we have the x-axis of the graph. On the x-axis we have time in seconds. In the y-axis I'll have displacement in meters. So this is 0 over here. Now the time is, I'll just do some divisions of the time. So let's suppose the time over here is 5, 10, 15, 20, 25 and 30 seconds. Displacement is 10, 20, 30, 40. So let's suppose there is an object that started its motion from 0 meter when time is 0. In the first 5 seconds it has covered a displacement of 20 meters. So it has reached over here. In the next 10 seconds it did not move, so it remained at the same displacement. In the next 5 seconds it has moved 10 meters more, so its new displacement became 30 meters. And in the last 10 seconds it has come back to the same position from where it started. So this is the graph for the motion of an object. So I'll just point out these different points. So I'll call this point as A, this is B, this is C, this is D, and this is E over here. So now I can find out the velocity between the points A, B, C, and D by measuring the gradient between these 2 points. So we can say that the gradient of the displacement time graph will give us the velocity. And in order to measure the gradient, let me just write down the formula for the measurement of gradient. So the formula for the gradient is y2 minus y1 over x2 minus x1. For example, this point is A, so it has coordinates 0, 0. This point is point B, which has coordinates 5 and 20. So this 0 will be considered as x1, this 0 will be considered as y1, this 5 will be considered as x2, and this 20 will be considered as y2. So I'll just insert these values into this formula and I'll get the gradient, and the gradient will give me the velocity from point A to point B. So so the velocity from A to B will be equal to 20 minus 0 divided by 5 minus 0, that is 20 over 5, that is 4, and the unit is meters per second. Similarly, if I have to measure the velocity from B to C, I'll do the same working. From C to D I'll do the same working, and from D to E I'll do the same working. So let's find out the velocity from D to E. Now in this one, the coordinates of D will be considered as x1, y1, and the coordinates of E will be considered as x2, y2. So over here I'll write it as 20, 30, and the coordinates of E are 30, 0. So the velocity from D to E, I'll just write it as DE. So this will be my x1, this will be my y1, this will be my x2, and this will be my y2. So I'll write it as like this: 0 minus 30 divided by 30 minus 20. So 0 minus 30 is minus 30, and 30 minus 20 is 10. So the answer will be minus 3 meters per second. Now this minus sign is showing the direction of the velocity, because as we have discussed that velocity is a vector quantity, so this minus sign will tell us that the direction of velocity is opposite. So this is how we can use the displacement time graph to find out the velocity between any 2 points. Alright, so after the displacement time graph, we'll discuss about the velocity time graph. So before drawing the graph, let me tell you the what this velocity time graph tells us. So the gradient of the velocity time graph gives us acceleration. If we want to know the acceleration between any 2 points, we will just measure the gradient of the velocity time graph. And the area under the graph, gives us the total distance covered. I'll show you how. Total distance covered. So these are the two informations that we can get from the velocity time graph. Now in this area, let me just draw a y-axis where we'll have the velocity, and in the x-axis we will have time. So this is the y-axis, this is the x-axis. So we have velocity In the y-axis the unit is meters per second, and we will have time in the x-axis, and the unit is seconds. Let me just divide this time into in the intervals of 5 seconds, and I'll divide this y-axis in the intervals of 10 meters per second. So it's 10, 20, 30, 40. Over here I have 5, 10, 15, 20, 25, and 30. So an object starts to move from 0, 0. This is 0 over here. Object starts to move from here. In the first 5 seconds it reaches the velocity of 20 meters per second. In the next 10 seconds it reaches the velocity of, in the next 5 seconds it reaches the velocity of 30 meters per second. For the next 10 seconds the object stays at the constant velocity. For the next 5 seconds it decreases its velocity to 10 meters per second, and in the next 5 seconds it decreases its velocity. It basically stops. So now let me just join these points. So from 0 to 5 it's like this. From 5 to 10 it's like this. From 10 to 20 it's a horizontal line. From 20 to 25, okay, let me just connect it. And from 25 to 30 it will be like this. Okay, so let me just number them. So it's A, B, let me just change the color. So this is point A, this is point B, this is point C, D, E, and F. So let's suppose I have to measure the velocity from between any 2 points. So let me just take point B and C. So okay, if you have to find out the acceleration from between 2 points, so I'll just find out the acceleration from point B to point C. So I'll write it as acceleration from B to C. So as I've written here that acceleration is equal to the gradient, so I have to find out the gradient between point B and C. So the coordinates of B are 5 and 20, and the coordinates of C are 10 and 30. So this 5 will be considered as x1, this 20 will be considered as y1, this 10 will be considered as x2, and this 30 will be considered as y2. So I'll just use the formula for the gradient, that is y2 minus y1 divided by x2 minus x1. Remember that when moving from left to right, you always have to take your first point as x1 y1 and your second point as x2 y2. So my y2 is 30, y1 is 20, so it's 30 minus 20 divided by x2 is 10, and x1 is 5. So it'll become 10 over 5, that is equal to 2. So 2 meters per second square is the acceleration from point B to point C. So from C to D you can see a horizontal line, and the gradient of a horizontal line is 0. So the acceleration between point C to D is 0, but it doesn't mean that the object is not moving. The object is moving at a constant velocity between point C and D. So this is the information that we get from the gradient of the velocity time graph. Now we'll discuss the now we'll find out the area under the graph, and the area under the graph will give us the total distance. So if we want to find out the total distance covered by the object from point A to point F, we have to measure the area under this graph. So let me just erase these points and I'll show you how I can measure the area under this graph. So in order to measure the area under this graph, I'll split this graph into small rectangles and triangles, and then I'll measure the areas of individual rectangles and triangles and sum it up, and we'll get the total area, and that total area will give me the total distance from point A to point F. So here you go. Alright, so I have 1, 2, 3, 4 triangles and 1, 2, 3 rectangles. So the area for this triangle will be half times base times height. So the base of this triangle is 5 and the height of this triangle is 20. So half times 5 times 20, that will give us 50. So 50 is the area of this triangle. Now let's see, for this triangle it will be half times base times height. So half times its base is 5 and its height is 10. Height means the difference from this point to this point, that is 10. So it will become 25. For this one, similarly, half times base times height, so its base is 5 and from here to here the height is 20. So half times 20 times 5, that will be equal to 50. And for this one, half times base times height, so its base is 5, height is 10, so it will be 25. Now the area of this rectangle is like length times width, so its width is 20, length is 20 and width is 5, so it will be like 20 times 5, so that will be 100. For this rectangle its area will be 10 times 30, so that will be 300. For this rectangle it's like 5 times 10, so that is 50. Now I'll just sum up all of the areas and I'll get the total distance. So I'll just write it over here that the total distance is equal to 50 plus 25 plus 100 plus 300 plus 50 plus 50 plus 25. So it will become 400, 500 and 600. So 600 meter is the total distance of this object that this object will cover in order to move from point A to point F. So this is how you can measure the area under the graph, and with the help of that you can say that this is the total distance that the object will cover. Alright, so up till now we are done with the motion part. Now we'll move on to the forces. So let's consider an example that on a straight rod there's a car that is traveling so this is the car that is traveling on the straight road. The force that is being provided by the engine of the car is towards the right, so we can call it the driving force. And the resistance or the friction that is being offered by the road on the tires of the car is in the opposite direction, so we call it as friction. So let's suppose this driving force is 1000 Newton. Newton is basically the unit of force, and the force of friction in the opposite direction is, let's suppose it's 300 Newton. Then we can say that the resultant force that is being applied on the car is the forward force minus the backward force. So this is how we can find out the resultant force. So the resultant force that is being acting on the car is the driving force minus the force of friction. So we can write resultant force as Fr, and driving force is 1000 Newton and the force of friction is 300 Newton. So the resultant force will become 700 Newton. Now from this information of the resultant force we can also find out the acceleration of the car if we have been given the mass of the car. So let's suppose the mass of the car is 1000 kilogram. So we can use a formula according to the Newton's second law, that says that the resultant force is equal to the product of mass and acceleration. So the resultant force, we can say it's equals to ma, where m is the mass and a is the acceleration. Alright, so because we have to find out the acceleration from here, so I'll make acceleration as my subject. So acceleration will become equal to resultant force divided by the mass. So the resultant force is 700 and the mass is 1000. So for this car, the acceleration is 0.7 meters per second square. So this is the relationship between the force and the acceleration, and we always have to use the resultant force while finding out the acceleration. Or if we use this formula, resultant force equals to mass times the acceleration. So if we multiply the acceleration with the mass of the moving object, then we can say that we have found the resultant force. And if there is a zero acceleration, then the resultant force will be equal to 0. So in that case, if the driving force becomes equal to the force of friction, the resultant force will become equal to 0, and the object will be moving at a constant velocity, hence the acceleration will be equal to 0. So that was the relationship between the force and acceleration. Alright, so after discussing the whole topic on forces and motion, let's do an exam related question. And let me tell you over here that the concepts that we have discussed, they are just the basics. So if anything that if any new thing comes up, then you have to be confident about that, and because the questions will not be exactly the same as of discussed in the basic concepts. So in the question there will be some additional points that will be asked, and you have to be prepared for that. Alright, so in this question it says some children launch a toy water rocket into the air. The graph in figure 2 below shows how the displacement of the rocket changes over time. So on the x-axis, whenever we have to see the graph, we always have to see what is in the x-axis and what is in the y-axis. So in the x-axis we have time, in the y-axis we have the height, which means we have the displacement. So the toy, it moved from distance of the height of 0, and after some time it reached at the top. So at the top, it reached at the top after 3 seconds. Then it began to fall down, and after 6 seconds it fell down on the ground. So now let's see part A. In part A it says describe in detail how the velocity of the rocket changes from 0 to 6 seconds. So we'll just say that from 0 to, okay, I'll just mark some points from here to here, and then from here to here, from here to here, and from here. Alright, so I'll say this is point A, this is point B, this is C, D, E, and this is F. So I'll say that from point A to B, velocity increases. And from B to C, because you see there's an increasing graph. It's not a straight line, it's an increasing curve. So whenever we have an increasing curve, it means its gradient is increasing, and from this graph, the gradient of this graph gives us the information about the velocity. So where the gradient is increasing, the velocity is increasing. If the gradient is in the positive direction, the velocity is in the positive direction. If the gradient is 0, like if the gradient is a horizontal line, gradient of a horizontal line is 0. So if there is a horizontal line, then we'll say that the velocity is 0. So we will move according to the gradient. So from here to here, the gradient of the graph is increasing. So we'll say from A to B, the velocity increases. Now from B to C, the velocity is constant, positive. Constant, positive. Like it has some positive value, because from B to C, you see there's a straight line that is going up. Now from C to D, the velocity decreases to 0. Decreases to 0 at point D. So when the object comes at point D, it will reach its final height. So when the object will be at its final height, it will stop for an instant to reverse its direction. So when it stops for an instant, at that instant the velocity is 0. Okay, now from C to D, from D to E, velocity increases in opposite direction. So as you can see from here, at this point, if we draw a tangent, this tangent will be a horizontal line. So the gradient of this tangent is 0. If you draw a tangent at this point, it's a decreasing line. So the gradient of this decreasing line is negative. So it will have some increased magnitude, but its direction will be opposite. So from D to E, its direction changes, and from E to F, I'll write it here. It came down with a constant velocity in the opposite direction. So over here, it seems to be a straight line. So we'll say it's a constant velocity in the opposite direction. Constant velocity in opposite direction. So this is basically the detail of the graph between point A, B, C, D, E, and F. So this is how you can explain. So you can say that from A to B, you can write it over here as from 0 to 1 second. From B to C, you can write it as, okay, let me just make point C over here. So you can write from 1 to 2 seconds, and then from C to D, you can write it here as 2 to 3 seconds, and from D to E, you can write 3 to 4 seconds, and from 4 to 6 seconds, you can say that constant velocity in opposite direction. So this is how we can explain this graph. Now let's move on to the next part. So the next part says, by drawing an appropriate tangent line on the graph in figure 2, estimate the maximum velocity of the rocket. So maximum velocity of the rocket, so we have to draw a tangent line to determine the maximum velocity of the rocket. So over here, the velocity has increased, but the most steep tangent that we will get will be over here. So we'll draw a tangent over here. That will be like that. And by finding out the gradient of this tangent, we'll be able to work out the velocity of the toy. So what I'll do is I'll take 2 points and we'll use the formula for the gradient and work out the velocity. So velocity will be equal to the gradient of tangent. Gradient of tangent. So I'll take this point as my x1, y1, and I'll take this point as my x2, y2. So this will be 1.4 and 15, and this point will be 1.8 and 20. So this will be x1, y1, and this point will be my x2, y2. So my gradient will become equal to y2 minus y1 divided by x2 minus x1. So it will be like 20 minus 15 divided by 1.8 minus 1.4. I'll just put that into the calculator and get the answer. So 20 minus 15 divided by 1.8 divided minus 1.4. So it will be 12.5 meters per second. 12.5 meters per second will be my maximum velocity. So this is how we'll do part B. Now let's see what's in part C. So it says, using your answer to part B, estimate the initial acceleration of the rocket. Alright, so we have to find out the initial acceleration of the rocket. Okay, so as I told you that acceleration is equal to change in velocity over change in time. So I'll consider that right over here at this time my velocity is 12.5 meters per second. So the change in velocity is 12.5 minus, initially it was 0, divided by, now the change in time, I'll take this middle point because this is the velocity between these 2 points. So I want to be as close as possible to the answer. So over here my time is 1.6 seconds. So I'll write 1.6 minus 0. So from here I'll get the acceleration. So it's 12.5 divided by 1.6. That will be equal to 7.8 meters per second square. 7.8 meters per second square will be my acceleration from the initial point. Now in the next part it says, explain how the rocket's average speed as it travels upwards compared to its average speed as it travels back down. Okay, so average speed is basically the total distance over total time. The formula for the average speed is equal to total distance divided by total time. So when the toy went up, it covered some height and some time, and when it came down, it covered some height and some time. So we will find out the average velocity speed in going up and coming back. So I think it's the same. Alright, so this is the graph. So when the toy went up, it covered a height of around 27.5 meters in 3 seconds, and when it came down, it covered the same height of 27.5 meters in the remaining 3 seconds. So we can say the average speed in going up and coming down is same. So I'll write it here. The average speed of toy and is same in both directions because it has covered same distance in same amount of time. Same distance and same amount of time. So the distance that it has covered in going up is 27.5 meters in 3 seconds, and while coming down it has covered the same distance of 27.5 meters in 3 seconds. So as I have told you that average velocity is the total distance over total time, so the average velocity in going up and coming down is the same. So this is it for an exam related question for the forces and motion. I hope you like it. Thank you.